Okay, I'm going to end with a couple examples that are a little more challenging than the previous ones, so make sure you spend some time understanding these. So solving x minus 2 equals the square root of 8 minus 2x. The first step in any radical or rational expression when solving is to isolate the radical. But it's already isolated, so note that there's nothing around 8 minus 2x. So because it's isolated, we can go ahead and square both sides since this is a square root function. So I'm going to square the left-hand side and square the right-hand side. Well, of course, the right-hand side, when you square that, just cancels out. So it's going to be 8 minus 2x. Now, the left-hand side, actually, I'm going to erase that. The left-hand side is a quantity squared, so remind yourself that that means you have to take x minus 2 times x minus 2, so yes, you'll be foiling, and the right-hand side cancels out. So you should be, I believe, good with foiling at this point. So x times x is x squared, minus 2 is minus 4, x plus 4. And then it should look fairly familiar. It's just a matter of getting all your like terms together. So I have an x squared. I'm going to add this 2x over the other side, which will leave me with not a plus 2x, a minus 2x. And I'm going to subtract 8 over, which will leave me with minus 4. And then it's either factorable, or if it's not factorable, then you would have to use the quadratic formula to solve. So are there factors of 4 that would add up to negative 2? And there are not. So unfortunately I have to go through the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a, and I'll simplify this a bit. So this is going to be negative 2 squared is 4, and then that's going to be plus 16 over 2. And 4 plus 16 is 20. And of course, I can reduce the radical of 20. And 20 is 4 times 5, so that will be 2 root 5. And both of these divide by 2, so that's going to be 1 plus or minus root 5. So I'm thinking that that's my answer, but of course you know with these radical equations you always have to go back and check your answer. So 1 plus radical 5, I'm just going to write this up here, 1 plus or minus root 5. And you need to check your answer. So what I would do, just to make your life a little bit easier, is take 1 plus root 5, dump it on your calculator, and I'm going to turn those into decimals. So 1 plus root 5 is approximately 3.2, and 1 minus root 5 is approximately negative 1.2. So now I'm going to put these two values, I'm going to start with 3.2. I'm going to put it over here and for x. So 3.2 minus 2 is 1.2. And I'm just going to... So let's see here. Checking. X equals 3.2. So 3.2 minus 2 is 1.2. And the square root of 8 minus 2 times 3.2 ends up being 1.26, blah, blah, blah. So because I rounded my answer, of course, that one appears to work. Then I'm going to check negative 1.2. And when I do that, a negative 1.2 minus 2 is negative 3.2. And I already know this isn't going to work because you're not going to be able to square root something and get a negative number. But just to carry it out, if I put negative 1.2 in up here, 8 minus 2 times negative 1.2 square rooted is a positive, oops, a positive 3.2. So because that doesn't equal, I know that solution is extraneous, hence the only solution is 3.2, or if you prefer, that was the 1 plus root 5 if you want to keep that in exact format. Okay, this last one then, notice it has two radicals, but it also has a -1. So the unfortunate thing about this problem is if I take this 1 and add it over here, then I'm unisolating this radical. So no matter where I put this one of the radicals is not going to be isolated. Because of that, I have no choice but to just square both sides. And the biggest mistake, or the most common mistake, is I'll see people, they'll square this, and they'll square this, and they'll square this, which is not balanced. If you square the entire left-hand side, you have to square the entire right-hand side. You can't square once and then square square. That's not fair. And yes, that rhymes. So I am going to square this entire side, and then I'm going to square this entire side. So the left-hand side is nice, cancels out to 4x minus 4. Unfortunately, the right-hand side, and this is going to look a little bit crazy, but you're taking this minus 1 times itself, and I'm going to write this out, right? So that's what that means. So kind of wrap your head around that. It's a ginormous foiling problem, but nothing you can't handle. So essentially I'm going to take this root times itself, which you know any square root times itself cancels out, so that's just going to be 5x minus 1. Then I'm going to have a negative root 5x minus 1 and another negative 1 times root 5x minus 1, and then negative times negative is a plus 1. So I'll carry this down. So if you look here, you have a negative 1 of the roots minus another 1 of the roots. So altogether, that's minus 2 of the roots 5x minus 1. And again, take a second to wrap your head around that. So negative 1 of these minus negative 1 more is negative 2 of that root. And then 4x minus 4. Well, now I have some like terms I can get together, so I'm going to subtract this 5x over, which will leave me with a negative x. Let's see, I have negative 1 minus 2, which is negative 3, plus 1, which is negative 2. So essentially all of that together I'm going to add 2, right? So that's going to leave me with minus 2. And then... Oh my goodness, sorry. I just made a huge mistake. Hopefully you caught that. Gosh, can I erase this? That was almost really, really bad. This negative 2 root 5x minus 1, I'm going to box that in. That's one big unit. So this plus 1 and this minus 1 cancel each other out. So I just have minus 4 still over here. And then I have negative 2 root 5x minus 1. So then I can divide both sides by negative 2. So I'm going to divide all of this by negative 2. That cancels out. And I'm just going to simplify this to 1/2 x plus 2 equals root 5x minus 1. And then I have another square root. It is isolated, and finally I'm kind of to a problem that should look familiar. So now I'm going to square both sides again. So if I square this, I'm going to get a 1/4 x squared. And again, I'm foiling this out. So this squared is 1/4 x squared. 2 times 1/2 is 1x, and then I'm going to have another 2 times 1/2, which is going to be a 1x, so 2x altogether, plus 4, and the right-hand side squared, of course, will just get rid of the radical. And combining like terms, I have 1/4 x squared. I'm going to go ahead and subtract 5x over, so that leaves me with minus 3x. Add the 1 over, so plus 5. And then I'm going to multiply everything by 4 just to get rid of that fraction. So I'll have x squared minus 12x plus 20. And then again, it's either going to factor or you're going to have to use the quadratic formula. So are there factors of 20 that add up to 12? And thankfully there are, so negative 10 times negative 2 would add up to that. So I'm going to go ahead and factor it down to x minus 10 and x minus 2, which means my solutions appear to be 2 and 10, but before I jump the gun I want to check for extraneous solutions. So I'm going to go back up to the top. X appears to be 2 and 10, and I'm going to plug them in. So I'm thinking x is 2 and x is 10. So if I plug 2 in, I'm going to have root 4 times 2 is 8, and 8 minus 4 is 4, and the square root of 4 is 2, equals 5 times 2 is 10, 10 minus 1 is root 9, which is the square root of 9 is 3, and 3 minus 1 is 2, so that solution appears to work. Then I'll do 10, 4 times 10 is 40, minus 4 is 36, and the square root of 36 is 6. 5 times 10 is 50, minus 1 is root 49, minus 1, square root of 49 is 7, 7 minus 1 is 6, and that appears to work. So no extraneous solutions in this problem. And that is the end of the challenging solving problems.